this lesson, we're going to talk about evaluating expressions. So an expression is a mathematical operation without an equal sign. And there are two different types of expressions that we're going to be working with. One is called a numerical expression. And a numerical expression is an expression containing only constants, powers, and operations. So basically, it's an expression with numbers and then addition, subtraction, multiplication, or division. Versus our other type of expression, which is called an algebraic expression. This is an expression containing constants, powers, variables, coefficients, and operation. And the big one to note there is variables. That's where we get the word algebra, is when we start throwing letters into the mix. Now, we need to know some essential vocabulary before we begin evaluating expressions. So let's go ahead and talk about them. The first vocabulary term is a constant. A constant is just a number in an expression. So you can see that I have an example off to the right. Number 12 represents the constant in the expression. Notice that the constant does not have a letter attached to it. It's just kind of like a Lone Ranger. Now, let's look at the word coefficient. A coefficient is a number multiplied by a variable. It's a number that stands in front of a variable and is being multiplied. So in this example, you can see that -3 is the coefficient of x. Likewise, 4 is the coefficient of y. Now, we already kind of been talking about this, but the word variable. A variable is a letter or a symbol representing one or more numbers. So you can see here that we have a couple variables. We have an x and we have a y. And the last thing we want to talk about is the word term. A term is a number, a variable, a product, or quotient, or not a sum or difference. Let me show you what I mean. In our example up here, you can see that I have 3 different pieces here. So I'm just going to go ahead and use these little lines here to show you. These are my 3 pieces. I've got -3x, which is considered a term. I have +4y, which is considered another term. And then I have my constant +12, which is another term. So this expression has 3 terms. Okay, now that we know our vocabulary, let's go ahead and see if we can answer some of these questions about this expression. So use the expression to answer the questions. Now, before I begin any problem like this, personally what I like to do is I like to go ahead and draw lines after each one of my variables. So this is going to help us answer some of these questions. I'm just going to draw little vertical lines right after the variables. Okay, number 1, what is the coefficient of x? So the number that is standing in front of the x and that is being multiplied is -3. Number 2, what is the coefficient of the y? You'll see that the number that's standing in front of the y is +6. Number 3, what is the coefficient of z? Now this is a little tricky. You have to use the operation that is standing in front of that number. So the answer to this is -3. Number 4, what are the variables in the expression? I have 3 variables in this expression. I have an x, I have a y, and I have a z. Notice how I placed commas between each one of those variables. And the reason for that is, if you wrote it like this, x, y, z, that is actually going to be considered as a term. So we always want to represent it with commas in between, just to kind of designate their, just that they're individual variables. Number 5, what is the constant in the expression? The constant here is -12. And the last one, number 6, how many terms are in the expression? Well, you can see that the lines are very helpful to answer this question because it breaks it into all of its terms. So we have 1 term, 2 term, 3 term, and 4 terms. So 4 terms in this expression. Let's go ahead and try another one. Use the expression to answer the questions. I'm going to go ahead and begin by putting my little lines right after my variables in the expression. Number 1, what are the variables in the expression? Well, I have quite a few here. I have an m, I have a y, I have a g, and I have an f. Number 2, what is the constant in the expression? Well, the constant is the number that's by itself. It is not attached to a variable. And that expression, or that constant, is positive 7. Number 3, how many terms are in the expression? Well, you can see here that I have 1, 2, 3, 4, and 5. Number 4, what is the coefficient of the m? Coefficient of the m is positive 5. Number 5, what is the coefficient of the y? Ooh, this is a really tricky one. We've talked about this in previous lessons, but anytime that you have a variable that's by itself and it does not have a coefficient standing in front of it, we can always assume that the coefficient is going to be 1. But in this case, we have a negative sign, so therefore our coefficient is -1. And the last one, what is the coefficient of g, which is positive 8. All right, now that we have talked about expressions, let's go ahead and learn how to evaluate an expression. We have one more vocabulary term, and that term is replacement value. A replacement value is a number substituted in for a variable. So looking at this first problem, it states if x equals 3 and y equals -1, evaluate this expression. Evaluate is another word that means solve, but the word evaluate is used for expressions, while the word solve is used for equations. Let's go ahead and evaluate this using its replacement values. What I'm going to do first is a little trick that helps you get the answer correct every time. Before I begin the problem, I am going to put parentheses around each and every variable that I see in the problem. It only takes a couple seconds, but it's very helpful. So I'm going to go ahead and start by writing -6, and then I'm going to put an x in parentheses, followed by a y in parentheses, plus 3. That's the first step, is to put those parentheses around the variables. Now I'm going to replace the values that I see. Notice that it says x is equal to 3 and y is equal to -1. So I'm going to go ahead and replace x and y with those values. -6, I'm going to replace the x with a 3. Notice how I'm keeping the parentheses. I'm going to replace the y with a -1 and then bring down my plus 3. Now that we have all of our numbers in there, you can see what happened here. I went from an algebraic expression to a numerical expression. And once you get to a numerical expression, you can simplify the expression using Pemdas. So let's go ahead and use our Pemdas. Okay, do I have any parentheses? Well, yes, I do, but there's nothing that's inside the parentheses that I can simplify. So parentheses are done. How about exponents? Well, I don't have any exponents here. So let's go ahead and move on to multiplication or division. All right, you can see that I have two sets of multiplication here. I'm going to go ahead and begin by multiplying -6 times 3. That's going to give me -18. And then I'm going to carry down my -1 plus 3. Let's go ahead and do the other set of multiplication. -18 times -1 gives me positive 18 plus 3. All right, the last thing I want to do is add 18 plus 3 to give me 21. So I evaluated the expression and then simplified using order of operations. Let's go ahead and try another. If x equals -2 and y equals 5, evaluate this expression. The first thing I'm going to do is put my parentheses around my variables. So I'm going to go ahead and take a moment and do that. Now I'm going to take my replacement values and substitute them in for my variables. So let's go ahead and replace an x with a -2. Notice how I'm keeping those parentheses. And I'm going to replace the y with a 5. Okay, Pemdas. I don't have any parentheses or exponents, so I'm going to move right into multiplication. So I'm going to go ahead and start with this set of multiplication here. So -5 minus 2 will give me 10. And I'm going to go ahead and rewrite the problem. And now I have 3 times 5, which is 15. So now I have 10 minus 15. And then the last one is 10 minus 15. Be very careful with your integer operations here. That's going to give us a negative number of negative 5. There we have it. We've simplified using our order of operations. All right, let's go ahead and just bump it up just a little bit and try some with a couple of exponents. Evaluate the expressions. If x equals 3 and y equals negative 2, evaluate this expression. Let's go ahead and start by putting parentheses around our variables. Notice in this one, I only have a variable y to work with, and that's okay. Even though they gave me a replacement value of x equals 3, I'm not going to be using it. Also notice that when I put my variables in parentheses, I did not put the exponent in the parentheses in the problem. I left it on the outside. Now let's go ahead and replace the letters with the replacement values. I'm going to go ahead and replace y with negative 2. All right, now you'll notice here that I don't have any parentheses that need simplified, so let's move on to exponents. My exponents here is negative 2 squared. Negative 2 times negative 2 is 4. So I'm going to go ahead and replace it with a 4. Notice how I'm keeping my parentheses. Now I have multiplication. 3 times 4 is 12. So now I have 12 minus negative 2. Okay, now I have to use an integer skill that we talked about quite a long time ago, where it's that double negative. Remember, when you have a negative and a negative next to each other, really what you're doing is you're adding. So I'm going to go ahead and change that to addition. 12 plus 2 gives us 14. And we're finished. Okay, I have one last one. If x equals negative 3 and y equals negative 5, evaluate this expression. Okay, let's go ahead and put our variables in parentheses. Remember, it's only the variables. Okay, notice how on that first term I have a negative out front. Make sure to keep it out front and don't put that inside parentheses. Now let's go ahead and replace the values. So I'm going to keep the negative there, and I'm going to replace the x with a negative 3. I'm going to replace the y with a negative 5. And I'm going to replace the x again with a negative 3. Okay, lots of negatives going on in this problem. Be very careful to follow the right procedures. Okay, there are no parentheses that need to be simplified. So now I need to move to my exponents. I'm going to go ahead and start with this exponent here. Negative 3 squared. Well, negative 3 squared is 9. So I'm going to go ahead and watch how I'm going to drop this negative here because I didn't use him yet. I just used the one that's inside parentheses. So it's going to be negative 9. And then I'm going to go ahead and take a moment and just rewrite it. Rewriting the problem really helps you just stay organized so you do this on a step-by-step basis. Let's go ahead and take care of negative 5. Negative 5 squared is negative 5 times negative 5 is 25. So negative 9 minus 25 plus 3 times negative 3. Okay, I'm moving away from exponents now, and I'm moving to multiplication. Let's multiply 3 times negative 3. Rewrite everything. And this time, watch what I'm going to do here. I'm going to add 3 times negative 3 is negative 9. So you can't have two operations next to one another without the parentheses in between, so be very careful. Now I have addition and subtraction, and in this case I'm going to do my subtraction first. Negative 9 minus 25 is going to give me negative 34 plus negative 9. And the last one we're going to do here is negative 34 plus negative 9. Now, again, this is really like saying negative 34 minus 9. It's going to give you the same answer of negative 43. All right, that brings us to the end of our lesson on evaluating expressions.